Well, good afternoon and welcome to Bulldogs Behind the Scenes, where we explore unique spaces, people, and research connected to the University of Minnesota Duluth. Today, we will take a look at the important work of the Natural Resources Research Institute. Before we begin, we're going to take a moment here to pause so that everybody has a chance to log on to the webinar. Well, my name is Molly Clevin, and I'm from the University of Minnesota Duluth Alumni Relations team. Today, we are going to take a behind-the-scenes look at the Natural Resources Research Institute. Before we begin, I'd like to highlight some of our past programs. We've explored places like the Minnesota Landscape Arboretum, Amsoil Arena, Superior Hiking Trail, the proposed UMD Sales Center, and the UMD Chocolate Lab, as well as the Romano Gymnasium and many more places. You can access all of these events on demand at our website, d.umn.edu/alumni. Today's webinar is being recorded and will be uploaded to our Alumni Relations website. You'll receive an email with the link once that is ready. Finally, we'll have time at the end of the presentation to answer live questions. To submit a question, use the question and answer button on the bottom of your screen. Now to introduce our guests. Today, we will hear from Rolf Wieberg and June Brenneman. Rolf is the executive director at NRRI. He came to Duluth to lead this organization in 2014 after a 25-year career in the industry. He received his bachelor's degree in chemistry from UMD in 1982 and went on to receive a PhD in inorganic and organometallic chemistry from the University of Colorado, Boulder in 1986. June is the NRRI Manager of Marketing and Communications. She's also a Bulldog, having finished her master's degree in journalism and English at UMD in 2004. She joined the team in 2001 as a public relations writer. It is now my pleasure to hand it over to Rolf.
Good afternoon, everyone. It's a real pleasure to have an opportunity as a fellow Bulldog and my fellow Bulldog, June, to present to you a little bit of a conversation about the Natural Resources Research Institute, which is a nationally unique research institute here at the University of Minnesota Duluth that is really differentiating the kinds of research we do here at the university and our ability to deliver that for society. We do a lot of work that's globally relevant. You're going to see that we're mission-driven and project-focused, and I hope to have kind of an exciting virtual tour with you as we go through the conversation this afternoon. So I'm just going to jump in, and we're going to talk through a little bit about who NRI is, how we started, what we do. And we're going to slide into talking about the strategic initiatives that we're driving, those trajectories and impacts, and of course, have some time for Q&A. So hold on to your seatbelts. We're going to have some fun moving through this fairly quickly and give you an opportunity to ask questions at the end. So when we look at the highlights, that if you don't remember any slide, and I hate slides because it's the kind of death by PowerPoint, but it's a way to construct a talk, but this slide is probably the most important to walk away with, is what are the highlights of what you remember about NRI? One, it's a very entrepreneurial applied research institute. We don't confer degrees. We engage students heavily, and those students get some applied research, real-world opportunities to work in real-world problems and deliver them with our staff. We're non-faculty, and there are about 140 full-time researchers plus students, and sometimes we swell into well over 200 people here at the Institute. We have very broad industry and regional relationships that are now reaching out into the international space with our partners in Finland, Germany, South Africa, and elsewhere. We have what we call a grams to tons demonstration capability, which is extremely important when you're starting to translate really great ideas into whether or not it's feasible and can attract investment. Because when you can do something in a test tube, that's neat. But when we really need to understand what the barriers to investment are It's how do you really understand the energetics and, quite frankly, the economics when you get into the tons demonstration capability. We really promote an integrated science and engineering model here. Silos don't solve problems. In some cases, they create them. And what we do is we work very, very hard to work with all of our stakeholders and partners to frame the research and then build a team around that project. And that team might change through the course of a project. Just because Bob, for example, does this kind of work doesn't mean Bob is that important through the entire project. And we really drive integrating our programs. You'll find a lot of our programs are populated by an ecologist sitting next to a mining engineer, sitting next to a geologist, sitting next to a water treatment specialist. Those are the kinds of teams we build. And finally, as I said earlier, we're nationally unique. We have other systems around the country asking how they can get an NRI. But we have these unique capabilities. We have the assets to do the work, as you'll see. But most importantly, we are in the geographies where it matters. Minnesota sits on probably the most rich combination of resources of any state in the country, including our people, ranging from the mineral to forest, to water, to clean air, to our people, energy storage, green energy, and the combination thereof, which is one reason why the Department of Energy is coming to Minnesota to seek out working with NRI directly. Exciting times. At the end of the day, what we really sell ourselves on is we're a unique collaborative partner. We believe in developing partnerships. Competition is good, but it also can lead to not getting the good work done. And we really work hard to partner with everyone we work with. So to kind of talk about how NRI fits into the University of Minnesota research enterprise, we're really the bridge between what we would call academic research and delivery of those integrated solutions. So we do participate in discovery research, application, demonstration. We drive those global impacts, which we try to deliver as knowledge and tools being perhaps a computer program that can help people understand impacts of logging, for example, developing practical solutions, and then, of course, driving commercialization, or another word might be adoption of this knowledge tools or practical solutions. So we look at ourselves as kind of the translational research arm of the University of Minnesota Research Enterprise. We have a system stance. We happen to be located at UMD, which puts us in a very, very unique opportunity to serve the system as well as UMD. So we start here in our conversation. Our challenge is essentially how do we continue to live as we understand it on this little blue ball while creating opportunity and still reducing risk. We have to be forward-looking, but be very mindful of the impacts that we have. Our role within the university is really predicated by the charter, which was provided by the Minnesota legislature in 1983, about the time I left Duluth. In fact, I remember seeing the sign on the edge of town as I left as a graduate that said, "The last one out of town, turn the lights off." The area of northern Minnesota was extremely challenged. Most of the industries were essentially shut down or struggling. And so the legislature at the time created the NRI with a joint charter, which was economic development as well as environmental stewardship. And we've carried that forward. It's a very far-looking charter that's still relevant today to our mission today. And the first four words of that mission are really highlighted here for a reason, because that's what we want people to remember. Our primary job here is to deliver. We are looked to by the legislature. We were created by them for them to make good decisions. And our job, particularly in the 2-year timeframe of a legislature, is to deliver, even in increments, what a solution might look like. We talked about the integrated research already, integrating across the institute, across partners to really deliver solutions that are much more comprehensive than an answer. If you want to know how to dig a hole, we can certainly talk about that. But when we want to talk about how do we manage our impacts and how do we derive value from our environment and our resources, having an economy and being just in delivering the benefits of that economy. That's our mission. And of course, if we're successful in that mission, our vision is to really help discover that economy of the future. The economy of the future is a conversation everybody wants to be a part of and see what we can do together and move things forward in a partnership fashion. Our taglines there you see on the bottom is driving integrated research, driving innovative science, and really driving the global relevance of Minnesota's impact on the globe. So what I want to do at this point is talk about that's who we are. Going into a little bit more about what do we do and what are these initiatives. And we talk about our work here. We manage over 150 different projects and programs at NRRI. And if I were to try to go through that, all of our heads would be spinning and I would be falling asleep. But what we've done is lay these out in a fashion to talk about strategic research initiatives that are really kind of the moonshots, the long-term sustained efforts that we see strategically we need to be driving. And we summarize these into these 3 strategic initiatives. And I'll start with ecosystem resilience. This is where our work starts and ends. Understanding the world we live in with some of the top scientists in the world, with reaching across all of our networks in the federal government, the state government, regional governments. How do we understand the world we live in on a very fundamental level, understand the impacts, and then how to manage them? That's the focus of ecosystem resilience. Future forest industries, just for a quick blurb there, we have 4 paper plants, for example, in Minnesota. All of them are very challenged. Each represents $1.4 billion of investment with a waning market. How can we turn those into new opportunities that fix carbon, provide jobs, make materials that don't require fossil energy, for example? Iron and minerals of the future. Obviously, Iron Range is a big part of the conversation in northern Minnesota. There are other minerals as well. How do we take advantage of these in a way that doesn't despoil our water resources and other resources? But also, how do we look at the renaissance of iron, for example? Iron is now being used for things, obviously steel, but when you start looking at energy storage opportunities, as in batteries, when you start looking at energy conversion opportunities, as in photovoltaics, yes, iron is now finding a way to be used in these, which is very exciting. A very abundant mineral. We don't have to go and extract really rare minerals in order to do some of the things that we depend on for our economy. All 3 of these are interactive because I can't talk about one without talking about the other. We can't talk about mining without water impacts. We can't talk about water and clean water without looking at our forest ecology. And the reason we have a lot of clean water in northern Minnesota is that we have very, very highly functioning forests. So bottom line, that's where we take innovation, which is one of our core values, and really focus on driving impacts for the state of Minnesota, the nation, and the globe. But how does this relate to the economy? A lot of us hear people talking about the food, energy, water triumvirate that defines the economy. And we really look at energy, water, and materials as driving the economy. Energy touches everything we do, and we need to be mindful of that. Energy is the biggest conversation in the country right now with the move to green energy, CO2 reduction, decarbonization. Water, you're not going to run much of anything, including life, without clean water, particularly as you start thinking about generating hydrogen with green energy. You can't do that with dirty water. And if hydrogen is going to be helping drive our economy in the future, we need to make sure we're taking care of it as well as using it properly. And of course, materials are important because that's what brings value to an economy, whether you're talking about steel or your hamburger. They're all materials, some we just happen to eat. So that's how we draw that's the mortar between our blocks, so to speak, of our strategic initiatives, is that we need to be focusing on making good, sound, long-term investments in our economy, which means that we need to be having environmental and economic justice at the same time as we're delivering success financially. NRI has looked at our mission and our goals and our initiative impacts. We've identified on the left as really addressing carbon in the environment and how do we manage it, driving a healthy environment, driving the social license to operate for industry, and of course, innovative industries. And you can see how we map against the UN Sustainable Development Goals in the color coding here. And this is one way that we really try to quantify and understand our impacts. For example, if we do some work in decarbonization of steel, what kinds of reductions in carbon does our work impact on both the state, national, and global scale? Decarbonization is one of the biggest conversations right now, as you see a little bit later, and we're working together and with the University of Minnesota to translate the work we do within the research enterprise into real impacts for the country and beyond. NRRI manages a whole host of relationships, actually hundreds, where we manage all these with software that lets us manage the relationship. We use customer relationship management software, so we really keep an eye on who we're talking to, what they need, what they really need, versus sometimes what they say they need, and we can really deliver some help across the board. Of course, the industry, we have strong ties with state, federal agencies. Federal is growing very quickly, a lot of international partners, et cetera. We're most focused right now on really driving development of our conversation with our tribal governments, as well as the NGOs, nonprofits, and our communities to help move the entire conversation regarding natural resources forward in a constructive fashion. Within the University of Minnesota, we are essentially a front door to the following programs in the University of Minnesota Research Enterprise as we engage industry, the federal government, and other international partners in really understanding opportunities for economic development using our natural resources. Our most important piece, though, is our people, and I'm always extremely proud to be able to talk about our people. Students come out here and they have fantastic experiences working within teams, sometimes multiple teams, to get some very, very important experiential learning-based opportunities, not only within the Institute, but with a lot of the companies and agencies we work with every day. If I were to circle on this partial picture of our lineup of all of our people that's in our foyer, I could circle at least 10 here that represent students that worked for us, did an excellent job, and became part of the organization long term. It's a great story, and these people come to work every day looking for a way to make a difference, and that's what really drives the ethos of NRRI. So I'd like to turn a little bit to talking about our facilities and how they impact our initiatives and those impacts that we're making. This is going to be kind of the tour, if you will, of walking through in a virtual fashion NRI. And we'll start. Ooh, this is supposed to be a video, and it's not. Well, I will bring this up at the end. June, perhaps you can help me there. But this is a movie that we'll show when we get done, when we get towards the question and answer section. But it outlines what I'm going to be talking about. So number one is we have our flagship site here in Duluth. It's out by the airport. You can see in the background. This is where we have well over 19 research labs, pilot areas for land and water studies, wildlife, forest products, minerals, materials, et cetera, where we have things like big bays. We can essentially build small factories to help people do that scale-up work, all the way to identifying what bugs are living in what stream and understanding the water quality, as you'll see. Here's a quick look at the front of the building as you enter on the upper left. Or on the upper right is a picture of our lobby, where you literally get exposed to who we are and our global impacts, of course, our initiatives. On the far right, you see a listing of all the crazy things at a highlight level we've done over the last number of decades. Note that we are this year 40 years old. That's always fun. We're proud to be modeling the Big M as a part of the research enterprise for the University of Minnesota, but being associated with UMD, you see in the lower right. And of course, that's June performing her role as really driving engagements, which you see as the lower picture. We engage customers, we engage the public, we engage clients, we engage agencies in conversations on our first floor, where you literally walk through our strategic plan and walk through some of the projects, as we will in a moment. We have another site called the Fens. This is a restored wetland that was once used to try to grow tomatoes for Gino Paolucci, those of you who remember Gino's Pizza. It returned to NRRI, and we have been spending a lot of time refurbishing it and selling wetlands credit. And we are now studying the Fens as a means to understand whether you can restore these to being active peatlands that are sequestering carbon for the long term. These are the fens and swamps and bogs are some of the most effective ways to store carbon that Mother Nature gives us. And we have NRI Coleraine. This is a 27-acre industrial site that used to belong to U.S. Steel. That's a pit lake in the back. It's near Grand Rapids, just to give you a reference point. But this is where we do a good bit of our metallurgy, mineral processing, biomass processing, and materials research. It's a large campus, and we're looking to make it larger with some of the interactions we're having with the federal government, as well as our industry partners, to demonstrate decarbonization technologies that'll help the globe. Here's a picture as you walk in to the laboratory. It's about 72.6 miles from the Duluth site, so we continually try to shrink that distance every day. So what I'm going to do now is I'm going to walk through each of the initiatives on a pretty high level, moving pretty quickly, but just giving an opportunity to show you some of the work we do, some of the assets we use to do it, and maybe seed some questions you might want to ask as we get into the Q&A. Again, ecosystem resilience is really looking and understanding the world, our impacts, and how to manage those impacts, mitigate those, particularly to our water and our forest and land ecosystems, which are, of course, intertwined. So some sample programs, we do quite a bit of ecosystem monitoring. In fact, our people are pioneering a lot of monitoring technologies, including putting little bitty backpacks on the backs of the birds you see there, the golden warbler, to understand their migration patterns. Same on bats that are suffering from white nose syndrome, understanding where they roost with these little battery backpacks so we can follow their movements. To environmental DNA, where you can see on the right with the people in the boat, they can take a mud sample from the bottom of a water body, and by doing DNA analysis, we can understand who's been there, whether it's a crayfish, a fish, a beaver, or whatever. We can understand what animals have been in the area. Instead of trapping them and trying to catch them, we can actually understand a whole lot about the ecosystem with sampling in a different way. We have, of course, a bird breeding atlas and forest management tools that and records that are being used now for forest management. The golden warbler, Minnesota is one of the few places that still exists because of the some of the tamarack swamps that are part of the Minnesota landscape. And this is, of course, of great interest to everybody, including from the federal government to the Audubon Society. But we also develop ecosystem information tools. If you go to our website, look at our the Natural Resources Atlas, you can access over 500 data sets, overlay them in a map form with no GIS experience, geographical information systems, which is fairly sophisticated, but you can overlay anything from demographics to water quality to hiking trails to minerals, and really understand what's in the state. And it's a really important tool that county planners, municipal planners are using to make good decisions for the long term. Of course, we also do a lot of work with water remediation. And on the lower right, we do a lot of sampling. And in the lower left, you'll see an example of one of the treatment facilities that we have literally put on a trailer and drive it around the state to demonstrate reduction in sulfate concentration in mine waters. So I like to talk about trajectories, and then we'll get into some examples. We, as I said, spend a lot of time in ecosystem assessment and remote sensing. We've spent quite a bit of money, millions of dollars, in contaminant identification and quantification, particularly with PFAS and some of the challenges related to that. We develop, as a result of that, all of that sensing and analysis, we're developing remediation materials to go after heavy metals, PFAS, sulfate, phosphate, and other materials. And then we develop process demonstrations that we, as I said, quite literally put on a trailer. You see some pictures in the lower right at the end of the slide there. That's a trailerized version of a sulfate reduction system that we've brought to 6 different water treatment plants around the state to demonstrate reduction of sulfate in natural waters. So it gives you an idea of, these ecosystem base sets, modeling tools, and invasive species management are some of the impacts that we're bringing to the state. So as you see some pictures here, we'll walk around the unit for a little bit. On the upper left, you have Michael Joyce, who is our wildlife scientist that really looks at, these are den boxes for fishers, really understanding where they live. And if we put the den boxes where they like to live, we start understanding how to harvest trees and where to be leaving trees with cavities in them so that these essential mammals have a place to live and have habitat while we help inform forest management decisions. In the upper right is where we have our teams looking at core samples from the bottom of lakes and streams to understand the health of the ecosystem and looking at all the microorganisms and, quite frankly, some of the monocellular organisms, understanding the health of the environment over time. On the lower right, you've got these are our tracker units that they use to track animals, whether they're a bird, a bat, a bear, or a moose. We do a lot of water analysis you see in the middle, as well as the DNA analysis, which is what they're doing in the middle picture there. And of course, there's a lot of microscope work. We've got top-notch scientists here. Actually, they're very unique across the entire country, being able to look at the taxonomy of who's under the microscope and therefore how healthy the environment is, and also understanding the invasive species phenomenon. This is a picture of Chris Philstrup talking to our Vice President of Research and the Associate Vice President of Research. They're in our EPA certified water analysis lab. This is a very important piece of NRRI, and it's a massive service to the EPA, because we're in charge of many, many base data sets that look at monitoring water all through the Great Lakes Basin, on the range, and other parts of the upper Northwest, Midwest rather. We've invested very heavily in a lot of repetitive types of pipetting that we do a lot of in this water analysis. On the right, you can see one of our technicians, that's actually a student, doing repetitive pipetting, which is a big part of the work we do. When we start getting into harmful algal blooms, which you've probably heard about, that can kill pets and make people sick, it's extremely important to do this reproducibly. And so we've invested in the Cube. That's a automatic titrator that allows us to do thousands of samples reproducibly with very low error and increase our quality in our work of identifying the hazard and the outcomes of the cyanotoxins that come out of these bacteria, out of these algae. Here's a picture of one of the labs. It doesn't look like very much, but standing behind and off to the side of these two scientists here is a $1 million piece of equipment that we have invested in. It's a triple quad mass spec, LC triple quad mass spec, for those of you that might know what that means, but it's a tool that gives us a very unique, as in all of the upper Midwest, capability of identifying well over 2,000 PFAS derivatives and identifying them and quantifying them. This is incredibly important as we do a lot of the work in some of the cleanup and remediation work we're doing, which includes our neighbor here at the airport. We take a lot of this data. Here's one of our staff that takes a lot of this data and builds maps with reams and reams of data. I once had a legislator throw a pile of data at me saying, what in the world am I supposed to do with that? And then we answered with the Atlas. And this is the capability we have within the Atlas tool to take reams and reams of data and make it immediately available to someone's understanding by looking at this on a landscape basis and understanding what the issues are, where they are, and how they interact. Here in this lab, this is another picture of some of the DNA analysis that we do when we take a DNA sample from a mud sample, for example, as I said earlier, where we can quantify understanding of who's there and how often are they there and how many are there. Here's a picture of some of our remediation technologies on the right-hand side and the lower left. This is a trailer where we're using a precipitation technology to take sulfate out of the water. In the right-hand picture, I guess both pictures, they're at the Virginia water treatment facility where we're taking the effluent there, and we were reproducibly able over a period of 3 months to daily show that we could reduce from the 70 to 100 parts per million to below 10. 10 is a low number, but it's also required to maintain the wild rice stands here in Minnesota. And this is a solution that we're delivering to the state right now with the MPCA to provide a fairly neutral cost to water treatment plants using existing infrastructure to be able to reduce the effluent from these municipal water treatment plants. In the upper left is a demonstration in our parking lot, actually, of swales and building swales with biocarbon and other materials to treat runoff from parking lots that range from hydrocarbons to heavy metals. And then, of course, there's another look at another one of our trailers. This one is a bioremediation trailer where we have a bioreactor in here that takes sulfate, converts it to hydrogen sulfide, and then traps that as either elemental sulfur or iron sulfide as we go through the process. All the trailers work on 1 to maybe 5 gallons a minute at the most, but it gives us real-time, long-term data to demonstrate these potential solutions to the state of Minnesota. So switching over to the future forest industries, we got a number of focuses here. We'll walk through the institute as we did with the earlier one. The role here is to really understand our forests and the impacts of climate change. Climate change is having a massive impact right now. There's an estimate of a 6-mile-a-year migration of tree species because of climate change. We are looking at hybrid plant species to really look at biomass stores and the opportunity to go after biofuels and bioplastics. Most of these are really targeting marginal farmland in the state. And then engineered forest products and really looking at biomass to energy and value-added carbon products are the focuses. Example, you've heard about our hybrid poplar for years, perhaps. It is now commercialized as of this year as something called Innova Tree. Grows 8 feet a year. It can be harvested within 8 to 10. Has a huge growth rate, uses lots of water, which it transpires, gives us an opportunity to look at phytoremediation as well as biomass. We're looking at functional biochar materials. A lot of people hear about biochar. What is that? Well, it's kind of a glorified charcoal, but we're bringing some serious science to that on behalf of the United States, frankly, looking at how can we manage the structure function of those materials so they can have specific functions, whether it is a additive to a concrete or whether it's something that's going to go and absorb PFAS preferentially. And of course, looking at engineered materials, beyond 2x4s, what are some of those mass timber panel developments and the thermally modified lumber spinouts that we've been working on over the years? So again, looking at 2 trajectories here. We have a thermal processing and chemical processing, starting with biomass, such as Innova tree and a lot of other materials. If we look at chemical processing, NRRI has a long history of extractives. For example, birch bark extraction has led to a number of materials that are full of antioxidants. Some are actually being trialed at the Mayo Clinic for anti-cancer activities. This leads into biopolymers and the resulting composites. We're working across the university system right now to bring these ideas to bear as we process biomass, which really has its focus on green chemistry, which is a short term to describe a major effort globally to replace organic solvents with doing a lot of reactions in water, which are much easier to clean up and protect the environment. Thermal processing, which is basically different levels of heating in the absence of oxygen. First is thermally modified timber going to biochar, and then to what we're calling this engineered biocarbon, where we're learning to manage the porosity and the surface chemistry to do something very special with surface modification. All of this is going to higher value carbon products that sequester carbon, they replace fossil carbon, and we really are investing heavily in biodegradation. When you buy a bag that says this is biodegradable, how do you know? Well, it turns out a lot of people really don't. And we're developing a laboratory here for, again, the upper Midwest to drive this with both industry and academia to quantify and understand what is a biodegradable material versus a material that kind of biodegrades and leaves a lot of plastic parts in the soils. So here's some pictures. We're going to walk through our greenhouse here. This is our breeding and our propagation of the Innova tree. And you can see the one on the right, the picture of the Innova tree. This was taller than I am, and I'm 5'10", when we went out into the real world and introduced it with the tag on there. This tree was 2.5 months old. These things really grow. And in the central picture, we're doing an experiment here looking at how these trees can be used for phytoremediation of contaminated water, whether it's sulfate contaminated or other. That's Ron Zalesny of the U.S. Forest Service and Chanlan Chun, one of our scientists, working together to characterize how these trees have been selected as probably one of the most important potential tools for phytoremediation of groundwater. Moving into our laboratories here at Duluth on the upper left, this is some very sophisticated equipment where we can understand the surface porosity of these carbon particles and then change the nature of the surface chemistry and make materials to do some of the remediation we're talking about. You can see we've got pretty extensive materials in the lower left. There are all of these things sitting there, those black pucks, if you will. These are polymers that we've been able to make here based on biomass-derived materials that might one day find their way into replacing the fossil carbon polymers that you find in things like car bumpers, et cetera. Obviously, we go from the left, which is a typical lab hood. This is one of the extraction experiments, to our semi-works area, where we can go from literally the grams to the kilograms. And this is where we are able to provide samples to industry, samples to consumers of some of the things we do so that we can understand how to scale up, which is, as some of you in the field might, you've heard devils in the details. Well, scale up, it has plenty of devils in those details, and this is where we do this work. This is some investment in making biocarbon. On the left side, you see a tube furnace, if you will, that allows us to look at different kinds of biomass. It might be a tree. We're now starting to move into waste cloth, maybe even some of the materials you might want to compost to try to develop these carbon-based sorbent materials. And on the right side, you see one picture of some of the biocarbon materials that we've made in the tonnage level. In the background behind our colleagues here is one of the large scale units that we use. You can see it's a rotary kiln. This is at our Coleraine site. It's the size of a train locomotive. And this is where we can essentially, quote unquote, roast the wood into a biocarbon product. As you see, our engineer is over on the right side taking samples of the biochar that's coming out of the process. Another treatment facility is here at the Duluth site. This is thermally modified timber, which is in short to take timber that we wouldn't normally use for structural purposes like a maple, because it warps and cracks and splits and absorbs water. But when you treat it, which is basically a low bake, if you will, lower temperature, you essentially polymerize the strings of cellulose and hemicellulose, drive out the water, take out the tar, and you come out of that with a material that's cross-linked. It's much less prone to rotting because it doesn't absorb water very well. It's stiffer, and it becomes a building material that has a specification that can replace some of the wood that's used, for example, in some of our window manufacturers, and they get that wood from New Zealand because it's nice straight grain wood. You want to talk about carbon footprint opportunities, there's one we're pursuing right now with our friends at Arbor Wood, this is Matt Arrow and Tim White. Tim's our partnership manager, and Matt runs the thermally modified program with Arbor Wood, who's now in business in the Brainerd area, processing wood into this highly water resistant, dimensionally stable material. And you see this is a walkway that is at the Zach Zim Bog here in northern Minnesota that demonstrates, and it's a great test bed for these materials. We make materials, but we also break them. And this is our materials testing lab. This is Victor Kraus, where we can take materials, condition them, and really understand what the specifications ought to be. We're helping drive those specifications in the industry. And we also use this facility to do testing for entrepreneurs and small businesses. For example, our friends at Lowell Design needed one of their chairs to be tested that's made out of recycled milk bottles. And so we ran a test for thousands of hours of people sitting in it and standing up and sitting in it and standing up. And that was required to be able to sell it in California, for example. Here's something we're really excited about. Here in the building, with some of our material development, we are developing in collaboration with Louisiana Pacific, who has a plant in Two Harbors, just up the road from us. But they wanted a place to innovate with us in new materials and have a place to test it and make it in their Two Harbors plant and install it and train their customers who will land at the airport a mile and a half away, come here, understand how to use their materials, teach them how to use their materials. And yes, we have a house inside NRRI. That is a demonstration site where they can take siding on and off using renewable resources here in Minnesota. One of their big focuses is sustainability and the reduction of waste when building houses, particularly with their siding products. Turning to our last initiative, iron and minerals of the future. One of the big focuses in this initiative is to really understand the remaining iron ore reserves and develop strategies to beneficiate those. As you might remember, the taconite process, which generates taconite for the blast furnaces in Indiana and Ohio, require a magnetic separation. A lot of the ores that we have been using are becoming less and less magnetic. And so we need to develop new strategies and new technologies to be able to utilize those iron resources that we're leaving in place at this point in time. But a big piece of this is how do we reduce the energy, water, effluent, and environmental impacts of mineral activities? Mineral activities and mining is incredibly disruptive. How do we manage that, and how do we remediate that? And overall, how do we decarbonize these industries utilizing the metals here in Minnesota? Some examples of the programs. We do a whole lot of industry engagement and assistance. Right now, we're heavily involved in introducing something called high pressure grinding roll technology, which is that big blue picture, that big blue piece of equipment on the left side of the picture over there. This is one of the only places in North America that has this laboratory capability, and this gives us an opportunity to reduce grinding costs, which is huge energy costs and CO2 dumps, by 40% for the mining industry here in Minnesota. So we're heavily involved in decarbonization efforts already. A lot of mineral resource characterizations and metallurgy here to help drive the conversation forward in terms of decarbonization. We have a large program funded by the state of Minnesota to look at iron of the future, whether it's going to be used for steel or for these other products we were talking about, including batteries and photovoltaics. And a lot of work in secondary product development. How do we sequester carbon, perhaps with some of the waste rock that we have? What kinds of things can we do with water treatments? Because some of the waste streams from the mining operations are actually quite good at treating water for things like phosphate. And of course, how do we use these materials for construction materials like roads and other opportunities? Again, we have a trajectory, which we start with resource characterization, understanding the extraction and processing steps to reduce the carbon footprint of the industry. For those of you that aren't aware, between steel and concrete, they represent up to 18% of the global carbon load. It's a global focus to decarbonize these industries, and we're a heavy participant in this work, both nationally and globally. As I said, secondary products, critical minerals will be part of our conversation as we go forward. Where to do it, how to do it, why to do it is part of the conversation that we don't participate in. But what we do participate in is the conversation about what is needed to, what kinds of technologies can be developed to prepare us. One exciting piece is looking at materials recycling. Right now, Minnesota landfills 90% of the electronic waste that we generate because we don't know what else to do with it. That represents some awful rich ore. And looking at this in tandem with the Ames National Lab and the Critical Materials Institute, we are starting to look at how can we partner up with them rather, to develop opportunities to really take advantage of these waste streams as to circularize that part of the economy. So walking around a little bit here in Duluth, we have a lot of expertise in the base geology of the state, a lot of the maps that talk about that geology at the scale that's necessary have been generated by NRRI, of course, in collaboration with Minnesota Geological Survey. So we do quite a bit of walking around in the woods on the right, as well as the mapping with Joyashish Thakurta and Sarah Post you see here. We also have a lot of expertise in looking at drill core, and understanding what's there, not only what opportunities are there, but what hazards are there as well. Because we have to be looking at the whole sentence, not the first three words, when we start considering mineral opportunities. We have some pretty sophisticated software to look at the mineralogy you see on the right. You start with the hand loop and go to the high-tech microscopes to really understand the morphology of these materials. Because what we're really trying to do is, if we can understand how they're put together, and we can understand those hazards, that is the geometallurgy that we need to bring to bear to develop the technologies in the laboratory space, to how can we best take advantage of these materials in a responsible manner. This is a picture of our Coleraine lab, where in this case, the team is working to bring up an automatic titration unit that will be able to accelerate our ability to evaluate iron resource samples, not only for how much iron is in there, but also what other materials might be there as well. This slides into what we call the wet lab at Coleraine, where we do the grams to half pounds demonstrations and developments research. On the upper left, this is the old, these are the Davis tubes that Dr. Davis developed the taconite process with we still use something very similar to it, where these orange things are big magnets that can concentrate the magnetic ore and separate it out. And this is one of the assays that we run that's very, very similar to what happens in the plants today. There's a rod mill in the upper right, a lot of laboratory space for the digestion in the lower right. And the left side is another part of the work area that is really it's a really, really cutting edge lab that we have that we're bringing a lot of our international partners through right now for iron research. This goes to the next level where we're starting to work with close to the tons, where we're developing and demonstrating the balling techniques that you'll see in the iron mines on the upper left and upper right. You can see that we do quite a bit of screening and sieving and grinding. All of these are in preparation for going into larger scale operations. This is a scale operation called a pot grate furnace, where we do large scale, multiple kilograms scale reduction of the materials and heating of the materials to generate the taconite pellets, and now going to the direct reduced grade pellets that are now going into the industry. And on the right side is one of the furnaces. We're pulling out one of the inserts that where we do these experiments. And yes, that is indeed red hot. So we do quite a bit of experimentation under fairly hazardous conditions, which is why our safety program is a key part of what we do. This is a view of the kind of space we have, which is extremely unique in a university setting. Yes, that's an overhead crane. Yes, that's a train track. We are working at scale in some of these cases and really taking it from the gram to the ton, as I said earlier. Here's another shot at the Coleraine site on the right picture. On the left, it gives you an idea of the scale of the buildings we have. On the right, this is actually a mock-up of the process at Mintac, which is one of the iron mines here in the state, where we are working hand in hand with U.S. Steel on a daily basis, where we literally built their plant in a miniature size so we could test the energy savings and water savings improvements to the process that we're working with them to introduce. Again, scale. So what's next for NRRI? This is the fun part, because we're seeing a very, very active federal government coming and engaging NRRI in everything from the U.S. Forest Service, trying to understand how we can really accelerate the use of these hybrid poplars for phytoremediation to clean up challenged sites, including Superfund sites from soil contamination and water contamination, to a rather large effort to look at what we're calling cross-sector decarbonization of the economy. In this case, Minnesota is extremely unique, as I said earlier. They want to work with us, NRI, to work on decarbonizing iron and steel in the state of Minnesota, but coupling that with the cement and concrete industry, because they intersect, couple that with biochar, because biochar can actually enhance the strength of concrete. In addition to locking up carbon, biochar can also be used as a coal substitute in the production of steel. And then couple that yet once again with e-fuels. These are like sustainable jet fuel. We have a major customer, you might have heard of them, called Delta Airlines, who is extremely interested in having a state source of renewable jet fuel. So by combining all of these, we take advantage of the IRA law that you've heard of to have multiple tax incentives to invest in Minnesota and, quite frankly, build that economy of the future over the next 10 years with that investment, to have a green iron and steel industry, a greener concrete industry, and drive the e-fuels industry that utilizes both our agricultural as well as forest byproducts to generate alternatives to fossil fuel. That's next. And that's why we're excited about our future and our trajectory, engaging partners not only here in the States, but also in Finland, Sweden, Germany, and beyond. So, we work hard, and, as part of the UMD and supporting Minnesota, if you're interested in working with us, we're always engaging our customers and our clients. And we have a fund where if you're interested in investing, we use this money to give our students that here at UMD an opportunity to come out here and work with us. We have lots of students, and as soon as they leave here, their resume is packed with real world opportunities. And we love to be able to support that with support from our I guess I'll call it our fan base, because it's a broad base. So I put that in front of you to consider. And I would like to finish by saying thank you to you for your time. Obviously, I'd like to thank the team at UMD for putting this together, because they were absolutely great to work with. And of course, foremost is to thank June Brenneman, who's just the greatest manager of our marketing communications here at NRRI that we could ever ask for. So I'll stop there, and maybe we can get that. I'll try while we're doing the Q&A, I'll try to retrieve that video. If not, we'll send it to each of you. It's about a 4-minute video that talks about essentially what I talked about. So I'll stop there and turn it over for questions.
Well, perfect. Well, thank you, Rolf, for that tour and overview of NRRI. We are now going to turn our video cameras on and begin taking our questions. So if you would like to submit a question, feel free to using the Q&A box on the bottom of the screen. We want to exit out of the screen, Rolf. That would be great.
There we go. Sorry.
And I did put, hello everyone, I did put our video YouTube link in the chat if you want to grab that right now. And it looks like we do have one comment in the Q&A already.
Mm-hmm. Yep, we have one comment in there, but there was a few other questions that came in through the registration. And so we will try to get through as many of these as we can. And if we don't get to your question, I'm sure we can follow up later through email. So to kick things off, Rolf, I know you talked a little bit about the different partners that you work with. There was a question that came in about tribal governments, and I'm just wondering if you can talk a little bit more about how NRRI respects the treaty rights.
Sure. I think probably right now I'll be very open about that. That is a learning opportunity at NRRI right now. We recently, 2-3 weeks ago, had Karen Diver, who is the tribal liaison for the university, come in and essentially train the entire organization on how to listen and how to think differently about how we approach our work. People like to talk about Western science and indigenous knowledge. It's the same thing. It's a different language. We need to listen to that language and work with each other. I think it comes down to when we talk about natural resources, our indigenous partners think about family members, which really comes to respect. And we're learning to do that. We're working actively, not only with Karen, but with the Blandin Foundation to expand our capability to do that. We just received a grant from the Blandin Foundation to fund NRRI and NREL, National Renewable Energy Laboratory, to work together to do those engagements. But it is a learning opportunity that we're pursuing very heavily with across the Institute.
And then on that similar vein of partnerships, do you work with any other organizations locally, such as Large Lakes Observatory?
Of course, yeah. We're heavily engaged with our friends at Large Lakes Observatory, which are part of that academic research. And we're part of the Water Council at the University of Minnesota. We're a founding member of that. So that leverages all the water science of the entire university into, we're part of that conversation. We also work with Minnesota Sea Grant, which does a lot of the extension work, if you will, for water around the state. But we also engage with a lot of the other entities around the country, whether you're talking about industry groups, whether you're talking about environmental policy and advocacy groups. We talk to everyone, we engage everyone, because everybody has a piece of the truth and everybody has a piece of the conversation as we frame the critical research gaps and programs to direct our resources at. But yeah, so we work across the university as part of the university research enterprise.
Perfect, thank you. And you had talked a little bit about the Innova trees. Wondering, are those available for retail sale?
Yes, they are, and we started selling them this year, and we were sold out in a week. Right now, it's on a trajectory. We're going to have more for sale next year. The demand is massive because the idea. Now, I have to say that these are not GMOs; they're hybrid. They're like mules. You plant it, and they're not going to spread. They don't have the cotton, so there's a lot of really good things about them. Propagating these things at the rate that people want them is the biggest challenge that NRRI is going after right now. But there's we can share a website with you that gives you an idea of how to obtain these. Maybe June, we can send that out to everybody as well. But it's a very successful product, and making enough of it for how many people want it. That's the biggest focal point right now.
And a couple of the questions that are coming in live, a lot of folks are curious about opportunities for volunteering. Do you have opportunities for folks to step up and serve?
Yes, we do. We have a number of things. We have an effort in citizen science in general that's driven by Tiffany Sprague, who runs a lot of those kinds of conversations. But we have many field teams in the summer, some of whom are populated by people that are volunteering their time. We have to vet people to make sure that you don't, while they may not be a university employee, we have to make sure people aren't going to get hurt. We're very focused on safety in the field, because you're going into a hazardous situation. So we do a fair amount of training. We take care of our people, but we're always we have more and more people interested in engaging with our scientists, whether it's citizen science or working on a specific project. And let us know who you are. We're happy to hear from you, and if we can pair you up with an opportunity, that would be to all of our advantage.
Great. And then this next question is just wondering about the different challenges that NRRI faces when combating climate change and embracing sustainability.
Yeah, I think we're all in. We're all in. That, like as I said, that's probably our primary conversation, because everything we do here really does lead back to that conversation about climate impacts. It is the crisis we're facing right now, and some of the things we're doing right today is having those conversations openly across the northern part of the state and the rest of the state and now the country. By owning that conversation from a point of view of what are the opportunities for us to make better decisions while still having an economy, that's what people want to engage on. So what are the, I think the question was, what are some of the things we're running into as challenges? Well, certainly resistance to change is one. Everybody wants change, but you go first. And if we're going to address this, we don't have a lot of time. And when I talk to our DOE colleagues, they point to the fact that the ocean warmed up 1 degree this year. When you think about the amount of energy that is alarming. So we really need to be focusing on doing everything we can to start thinking about how do we, as I say, cross-sector couple a lot of these ideas and a lot of these opportunities so that we can make the biggest impact on carbon reduction while having access to some of these materials that we have to have an economy. So the challenges are getting people to the table to have the conversations about what is a productive, but let's see, what's the sense of urgency about creating those understanding those gaps, creating the right research programs that are focused on delivery and demonstration so that we can, frankly, implement these things in the next 5 to 10 years. There's a sense of urgency. So that's kind of a runaround answer, but those are the conversations we're engaged in pretty actively, very actively right now. And that's what we should be doing as part of the University of Minnesota.
Perfect. And Rolf, I know you talked about was it 150 plus projects that NRRI is working on, knowing that there are so many different initiatives. June, maybe you're able to answer this, but how can folks, I think I saw you dropped in the chat box, but how can folks stay updated on the different initiatives and research projects?
Yeah, I did put our website in the chat. We have a sign up for a monthly newsletter. This is something where I put my journalistic skills to work and deliver some stories that talk about in a understandable and quick and easy read. So I put that out monthly.
And I'll interject here. She's an award-winning author doing that. So it's worth reading. And she does a fantastic job of making it accessible and fun. And even my dad likes it. So
yes, my biggest fan. No, it's great. Thank you.
And we'll also, so after this webinar, we will send a follow-up email to everyone that attended as well. So those links will be definitely available. So I know we're running a little bit short on time here, and I would just like to end on, this is a question for both of you. What brings you to work every day? What is exciting about the work at NRRI that keeps you coming back?
Good, June, you go first.
Well, I've been at NRRI for 22 years now. I started as the PR writer in 2001. And it's just been an amazing journey watching the growth and changes of projects and emphasis and all the different ways that we make an impact. It's never boring. It's always exciting. So you got a good dose of it here today.
That's great.
I'll jump on that. When I was asked to consider this job, I had no interest in it. I had the job I'd fought for 25 years. I was at the DuPont company. I was having a blast, and then I get a call from people like June saying, you should come here and take this job. And my initial answer was, I have a job. I'm good. And because I was an alum, Dr. Carlson in the chemistry department, who's the guy that jerked me out of a practice room, as I was a trumpet major at the time, and got me into the chemistry lab, and that was it. I was caught. He called me up, said, "You probably need to take a look at this because we want to have somebody like you in here." So I ended up coming and talking to people, and became immediately convinced that I needed to do this because of two things. And one is the people. The people here, I'd go to war with any day, because they come in here and they are working their hearts out to do what I call to make a difference. And I think when you look at the critical nature of NRI's work on the globe, not much less the region, this is where it's got to happen. And this is what gets me out of bed every morning, because when we can say we're taking a chunk out of some of the challenges that are facing us as a globe. I noticed in one of the questions, are we involved in nickel mining, copper nickel? Of course, we're involved in looking at what those impacts might be and what we might do about it. How do we have that forward look? And as I like to say, and everybody hates it, but it's a Wayne Gretzky thing, our job is to be where the puck is going to be. And the thing that gets me out of bed every morning is that we are where the puck is heading. And we are working every day to be prepared to take that slap shot. Just to play the UMD Bulldogs theme there for you. We want to hit the goal, and we don't have time to waste. So hopefully that answers the question.
certainly does. Well, and on that note, thank you both for just taking the time to be with all of us today and sharing about this unique resource and the exciting research. And for those of you that this is your first time joining a behind the scenes, our Office Alumni Relations hosts these sessions about 1 to 2 times every month. So if you'd like to be on that mailing list, feel free to email us and we will get you on that. So with that, just thank you both for being here, and we hope you'll all join us for future alumni events. Thank you.
Thank you, Molly. It was great. Bye, everyone.
Thank you.